All right, so we're just going to do some examples right here of stacked graphs. Now, the kind of unhelpful part about this is the fact that they are not stacked vertically, and it would really help if my screen were more vertical than it is horizontal. But try to picture these stacked vertically, just like we did before. So you've got position versus time. All right, you've got velocity versus time, and acceleration versus time, all stacked vertically like that. So we can't really do that just because of the space that we have right here. But that's all right, because maybe you should be able to learn how to do these without stacking them anyway. All right, so if an object is at rest, do we know where it's starting? No. So that means we can pick anywhere right here. I'm just going to pick somewhere, I don't know, somewhere crazy right there. All right, if it's at rest, it is not changing its position. So over time, the position will remain the same, just like that. Well, I think that's the straightest line I ever drew. I'm going to erase that at the end and just make it perfect. There we go. All right. So over time, is the velocity changing? No, it's not. It's at rest. It doesn't even have a velocity. Well, it does, but the velocity is 0. All right. So no velocity change over time. And if the velocity is not changing, acceleration is not changing over time either. All right. That was easy. And that's kind of like the first example, or the first practice one that we did. Okay. Object with a positive constant velocity. Okay, so this is helpful. Starting from the origin. All right, so it tells us where we're starting from. So let's go over here on the position versus time. All right, starting from the origin, it's got a positive constant velocity. Remember, velocity is change in position over change in time. So that means it's the slope of this line right here. So we're going to have a positive constant velocity, just like that. All right? Could have been a little straighter line, but you get the idea. Okay? Our change in position over a change in time, that's our velocity. And if we have a constant positive velocity, then over here on this graph, that's going to be somewhere up here, right? Because now velocity is on the y-axis. Except now, if it's a constant slope here, then that means it's going to be a constant y value. That's not very constant. Let's undo that. It's going to be constant y value right here. All right? This velocity is not changing. This, I don't know, what is it, 3 meters per second? I don't know. It's the same thing that it is here, as it is here, as it is here. Constant velocity. So there is no acceleration. Acceleration is going to be 0. And if you recall, acceleration being a y value right here, the y value here is based on the slope right here. Well, there is no slope, so therefore that gives us no y value. Well, a 0 y value for acceleration. So that's how these graphs would look. Sloped, a positive constant y value, and then a 0 constant y value for acceleration. All right, next. Object with a negative constant velocity starting from the origin. Okay, so that helps us. We're starting from the origin, but now it's got a negative constant velocity, which means that line is going to be going down like that. Velocity is not changing. That should tell you something about acceleration right here. But this is going down like that. You guys hear my dogs growling in the background? They're fighting over a toy. All right, that's a negative velocity right here. How do we know? Because we've got a negative rise, or what do we call that, a sink? A negative displacement over time. So it's moving in the negative velocity direction. Okay, remember right here, this slope right here is the y value over here, because if this slope is velocity, and all these y values are velocities right here, then how would we write this on the velocity versus time graph? Well, it's a negative. So we would have to pick a negative slope. I don't know what it is, a negative value. You guys hear all that crashing around in the background? I'm sure that's highly entertaining. Koa, will you stop it, please? And since this slope is constant, let's make this into a constant negative y value right there. All right, so that's a negative v something. I don't know what it is, but it's not changing. Now, once again, The slope of this line is, just like we did before, is the y value for the next line. Well, there is no slope, so therefore the y value is going to be 0. Velocity is not changing here. So therefore, there's no acceleration. There's no change in velocity over time. So acceleration is 0. All right, here's yet another one. Object, for Pete's sake, Koa, knock it off. I'm going to take that. Yeah. Hopefully it's not bothering you guys. You're probably laughing your heads off, actually. All right. Negative constant velocity starting from in front of the origin. In front of the origin. All right, so that really means positive to the origin. All right, this is going to be interesting right here. Okay? So it's starting here. It's starting positively. I'm going to move this because he's just making way too much noise. Sorry, moving to a different room. The dog is just crashing around being an idiot. All right, so we're starting positive at a positive position, but it's got a negative constant velocity. Check this out. So the velocity is constant, so there is no acceleration, but it's doing that. All right, so it's going from a positive position to 0. Now to negative. Kind of like we did way back at the beginning of this graphing section where something was moving positive and then it was moving negatively right there. Okay? We've got a negative constant velocity because we have a negative displacement over a change in time. Okay? What does that mean over here? Well, remember, this y value, the y value right here, depends on what the slope is right here. And if we have a negative slope, negative velocity, then, I don't know, whatever that is, some negative value, we're going to have so we've got a negative constant slope on the first graph, we're going to have a negative constant y value right here. All right, that wasn't too bad. How about this last one, acceleration versus time? Well, once again, the y value on this graph equals the slope from the previous graph. Well, if this whole graph, the slope is 0, 0, 0, 0, then again, poor acceleration gets left out and has no slope and no y value at all. And that makes sense because it's a constant velocity. There is no acceleration. There's no change in acceleration over time. Okay, we finally have acceleration. That's good. All right, we've got a positive acceleration, so acceleration will be happy. Starting from rest at the origin. Okay. So let's start right here. Let's start at acceleration right there, okay? All we know, we don't know what the value is, but we do know that the acceleration is some positive value. So hooray for acceleration. It finally has some positive value right there. Now remember, in our whole course, that's not going to change. You're not going to have a sloped acceleration because that would be something called jerk, which we're not going to deal with. We're dealing with positive, I should say, constant acceleration, and that should indicate that. All right, it's a constant value. But remember, the y value of this line indicates the slope of the previous line. So if it's got a constant acceleration, then that means positive acceleration. We're going to have a constant positive slope right here. All right? We have a constant change in velocity, or sorry, a positive change in velocity over time. That's indicated by the acceleration. That makes sense. All right? So what does that mean for this graph over here? Well, remember, the slope here equals the y value of the next graph over. All right, so since this y value here is changing, getting greater and greater and greater and greater and greater, this is kind of like I did before, the slope starting at the origin, all right, starting from rest at the origin, is going to get greater and greater. So no slope over time, greater slope, greater slope, greater slope, greater slope, and so forth. Now it's a little off, it's not perfectly lined up, but hopefully that makes sense that as these y values increase, these slopes increase and increase and increase and increase. So you can see we're going to have a curved line like that. A curved position versus time line means you're going to have an acceleration, because the acceleration is what is causing that position versus timeline to curve. I'm going to stop this video for now, and so the next 5 examples we're going to do in a separate video. And again, hopefully maybe my dogs won't be irritating you then. See you then.